Now, in this video, we are going to take up one more problem on projections of lines. How to analyze and solve the problem using manually. A line capital AB has its end capital A 20 mm above HP and 15 mm in front of VP. The other end capital B is 60 mm above HP and 45 mm in front of VP. The distance between the end projectors is 70 mm. Determine apparent lengths and true inclinations. So this is the problem. So what he says, end A is 20 mm above HP and 15 mm in front of VP. That means one end point of the line capital AB has been given with respect to HP and VP, and he has also given the other end point, which is also 60 mm above HP and 45 mm in front of VP. So it means he has given the locus of both A and B of capital AB, and he has also given the distance between the end projectors. So how to solve this problem? So to do that, first what I need, so I will going to plot this in 3 dimensions first. So what is that? He says NDA is above HP by 20 mm and in front of VP by 15 mm. So as we look from the front view, I can see the distance above HP, that is from this point to this point, which is capital A, which is 20 mm above HP. When you look from the front view, I can see the distance on the vertical plane. So you will get A dash. Similarly, when you look from the top view, he has given the distance in front of VP, which is 15 mm. So that is, when you look from the top view, you can see the distance from small a to this point. This is 15 mm in front of VP. If you join these two, then you are going to get the capital A in space. Similarly, he has given the other end point B. So what the other end point B is, when you look from the front view, I can see the distance above HP, which is 60 mm. That is from here to here. This is the distance, which is capital B is above HP by 60 mm. When you look from the front view, since the front view is perpendicular to this line, so that will be projected onto the vertical plane, which will going to be the locus of B in the front view. Similarly, he has given the distance in front of VP, which is 45 mm. So when you look from the top view, that is from this view, I can see the distance from here to here. So when you look from the top view, that point will going to fall on the horizontal plane where you have got small b. So now we have got the locus of B in the top view. So, and you have the locus of B in the front view. So what does it mean? The locus of B means the other end point of the capital B, that is maybe the front view, and also the true length will going to lie on the front view of this locus of B. Similarly, the point B and the true length of the point, the top view of the point B and also the true length of the top view will going to lie on this locus of B in the top view. So when you look from both front view and top view, you can see the distance in front of VP, that is this distance which will be seen in the top view, that is here. And when you look from the front view, this distance which is above HP, which can be seen in the front view, that you can see here. So you are going to get the locus of B in the front view. But he has also given the other distance, that is the distance between the end projectors. What is the distance between the end projectors? When you look from the front view, this projected point will going to lie on this. Similarly, when you look from the top view, the projected point will going to lie on this locus. So when you join between this B dash, the distance between the end projectors. So what is the distance between the end projector? We have the end projector A and we have the end projector B. So this is the end projector in space, and this is also the end projector in space. The distance between the two, when you look from the front view, since it is front view is perpendicular to the viewing direction, so then that point will going to lie on this. And similarly, when you look from the top view, the end projector distance will going to lie on this line, the projector A. So when you look from the front view, so this is the projector what we are talking about, and here also this is the projector which I am talking about for the front view. So when you look from the front view, that projector will going to be this, and similarly the projector what we have here is this. So what is the distance? That distance is 70. So from the projector A, if you measure this distance, which will going to be 70, and when it is projected onto the locus of B, it will going to cut the locus of B here. So then this you call it as B dash. Similarly, when you look from the top view, this is the end projector of the point A, which will going to lie here, and this is the end projector distance of this point. This is the line. When you look from the top view, that projector will going to lie on the horizontal plane here. So this is the distance what we are talking about. Since from in the vertical plane also this distance is 70, in the horizontal plane also this distance is 70. Therefore, both in the front view and also in the top view, they will going to lie on the same line. And since the front view end projector will going to lie on the locus of B here, and the top view locus of B will the top view, the distance between the end projector will going to be 70, which will going to cut the locus of B in the top view here. So this point will going to be B, and this point will going to be B dash. So where it cuts the locus of B in the front view and where it cuts the locus of B in the top view, these two points are called B dash and B respectively. So then, as we have joined between capital A and capital B in space, similarly when you look from the front view, that image will going to be from A dash to B dash, and similarly when you look from the top view, you have the line capital A and capital B, and that you can see which is being joined between A and B with a dot line. So this is the capital A and capital B in space, and this is small a and small b, which is the top view, and in the front view which is going to be A dash and B dash. Now, how this can be represented in two dimension? So how can I do? I will going to draw an XY line, and we will going to mark VP and HB. Then you take from XY line, you measure the distance above HB, which is 20 mm. So that is this distance what I am talking about from three-dimensional space, and I will draw a horizontal projector. And similarly, when you look from the top view, you can see the distance which is in front of VP, which is 15 mm. So that 15 mm what I am talking about. From XY line, you measure 15 mm and draw a horizontal projector. You take any convenient point on the projector A from the horizontal line of A, and then draw a vertical projector such that both these two points will going to cut at these two lines. So you mark this point as A dash, and you mark this point as small a. This is capital A and this is capital B, and show the dimension of 20 and 15. Then from XY line you measure 60 mm because he says 60 mm above the HP and 45 mm in front of VP. So from XY line you measure 60 mm and draw a horizontal projector here. Similarly from XY line, which is you take 45 mm in front of VP. In front of VP is seen in HP. Where is HP? HP is below the XY line. So from XY line you measure 45 mm and draw a horizontal dash dot line. And you mark this as locus of B, and you mark this as locus of B in the front view, and you mark this as the locus of B in the top view. So then you know this is the end projector point for A and the distance between the end projectors. So from here you measure 70 and draw a vertical projector. This will going to cut in the vertical plane at this locus of B, and here in the top view it will going to cut at this locus of B here. Then mark this point as B dash and mark this point as B, and this as locus of B, and here also locus of B. Then join A dash B dash with a dot line and AB with a dot line in the top view. Now you know the front view and top view. How do I know that this is the front view? Because the top view line is inclined. You know this is the top view because the front view line is inclined. So you have capital A and you have capital A in the both front view and as well as the top view. So we have the front view and top view is given. So what I need to do? I need to find the true length of the line. So to do that, so what should I do now? So this is the line in space what we have. So here what I want, if I want to find the true length in the vertical plane, what should I do? I should make the line parallel to VP. Which line I should make parallel to VP? The line which is inclined to VP. So which is the line which is inclined to VP? You can see that this is the top view line which is small AB. You have to make it parallel to VP. So the line in space with capital A as center, taking the distance of capital A to B. At present, what is the distance of the capital B in front of VP? At present, the distance with respect to VP, the capital B is 45 mm in front of VP. But what is the, if I want to make this line parallel, that B1, capital B1 should also be in front of VP by the same distance what the capital A has. The capital A has 15 mm. So from capital A, with this as center, you hold this line capital B and then rotate such that capital B will also be in front of VP by 15 mm. You can see here, this is the distance what I am talking about. So this is capital B1. So when you look from the front view, that image will going to be projected onto the locus of B in the front view. So you mark this point as P1 dash. And now since this line is parallel to VP, you mark this as capital B and join A dash B1 dash. So this is how I will be able to find the true length in the front view. So now true length in the, this is how we will be able to find the true length in the front view. So when you are rotating this in space, what happens on the image? Because we are trying to represent only the image, not it in 3D. So as we rotate with A as center, the radius as AB, when I am rotating in space, what happens to the image in the top view? The image in the top view which is AB, which is the top view image. So this is the capital A and this is capital B. So when you look from the top view, you have small AB here. So this is the top view image. So what I am doing is, as we rotate it in space, what happens? The image in the top view is also getting rotated. So that is the reason why with A center, taking the radius of AB, you draw an arc such that both A and B1 are in front of VP by same distance, that is 15 mm. Therefore, the line capital AB1 is parallel to VP. Because when if the top view line is parallel to XY, correspondingly in the front view, that line is in true length. You can see that A dash and B1 dash is the line which is the true length of the line in vertical plane, because that line is parallel to VP. Since it is parallel to VP, where that image I can see the parallel to VP in the top view. So that is the reason why I told, if the top view line is parallel to XY, correspondingly in the front view, that line will be in true length. So since the line is in true length, so you will have capital A and capital B in the front view. You mark that angle as theta. So how to represent that in orthographic view? So with A center, by using the compass, with A center taking the radius of AB, you know this is the top view because the front view line is inclined. With A center taking the radius of small AB, you are rotating such that you make that AB1 parallel to XY. That is, A is in front of VP by 15 mm and B1 should also be in front of VP by 15 mm. Then only the line will be parallel to XY in the top view. Its corresponding front view. A means A dash, B1 means B1 dash. Its corresponding front view will going to be true length. Then from B1, after rotating and make it parallel to XY, then you mark this point as B1. With this as center, now from B1, you draw a vertical projector to the front view such that it will going to cut the locus of B in the front view. Since this top view line is parallel to XY, Correspondingly, in the front view, that line will be in true length. You mark this point as B1 dash and you mark this point as capital B bracket, and of course this is the locus of B. Join A dash B dash with little bit thicker than the XY line. You mark this line angle as theta. So this is how I will be able to find the true length with respect to this is how we will be able to find the true length and true inclination with respect to HP. Now, similarly, I have to do it in the top view. How to do it in the top view? How to do that? So that means with A center, now what we want, now the line is in space. I want to find the true length in HP. Since I want to find the true length in HP, what should I do now? I should make the line parallel to HP. So that means, what does it mean? The position of the point B, which is now at present, this line is above HP by 60 mm. What I want the true length of the line, true length in HP. Since I want to find the true length in HP, obviously that line has to be parallel to HP. So with A center, taking the radius of capital AB, you are rotating in the clockwise direction, you can see here. So that means A is above HP by 20 mm, then B2 should also be above HP by 20 mm, then only the line is parallel to HP. Since the line is parallel to HP, you are getting the true length in HP. You mark this point as AB2. Okay? So, while doing so, what happens in the front view? What is the position of this point capital B in the front view? That is B dash. Okay? So, as we rotate capital A and with A center, capital B, AB as the radius, when you are rotating in the clockwise direction, what actually is happening is the point which is above HP by 60 mm, you make that point B also above HP by 20 mm. Why? Because I want to find the true length in HP. Since I want to find the true length in HP, both capital A and capital B2 should be above HP by the same distance, which is 20 mm here and here also 20 mm. Now the line is parallel to HP. See what happens when you are looking from the front view. So what is the present position of this front view? The present position of this front view for this is A dash B dash. So as we are rotating capital with A as capital A center with AB as the radius, when you are rotating such that both B and B2 and A are above HP by 20 mm. So when you are doing like this in space, what happens to the image? As we are looking from the front view, A dash with A dash center, taking the radius of A dash B dash, you rotate in a clockwise direction such that the B2 dash is also above HP by A dash. So then only the line will be parallel in the front view. When the line is in parallel in the front view, correspondingly in the top view, that distance will going to be in the true length. So that is the reason why we are rotating like this, and then we are projecting in this direction, and also that is I have joined to this line, and from here I want to join this. So you are going to get this point B2. Then join small a and small b2, and this will going to be capital A here, and this will going to be the capital B. How do I know that this line is in true length? Because both A and capital B2 are above HP by 20 mm. Therefore, the line is parallel to HP. Correspondingly, in the top view, that line is parallel to HP. Therefore, in HP, I will going to get the true length. So, what does it mean? If I want to get the top view line is in true length, therefore, in the front view, that line, which is that line, AB2, that line in the front view will become A dash and also B2 dash. Now the line, the true length of the line which is parallel to XY line in the front view, obviously that line will going to be in the true length. You mark this angle as phi. So So how to find the true length in the horizontal plane? So if you want to find the true length in the horizontal plane, that means in the top view, if I want to find the true length, the front view line has to be parallel. So which is the front view line? The front view line is A dash B dash. How do I know that A dash B dash is the front view? Because the correspondingly in the top view, that line is inclined with a small AB. So with A dash as center, taking the radius of A dash B dash, draw an arc such that both A dash and B2 dash are above HP by 20 mm. Therefore, the line will going to be parallel to HY in the front view. Obviously, that line AB2 will be in true line. Therefore, you represent this as capital A and you represent this as capital B. And you mark this angle as phi. So now, join A, B2 with little bit thicker than the XY line. So then by using the scale, you measure A dash B dash, you measure A dash B dash and also AB. So you are going to get A dash B dash up to second decimal point is 80.62 mm, or you can take it as 81 mm. In manually, AB is 76.16 mm, then you are going to take 76, and then theta, it is the true inclination with respect to HP, which is 27.71 means 28 degree, and in phi 20.41, that is the true inclination with respect to VP is phi, true inclination with respect to HP is theta. Then the phi angle will be 20.41 degrees. So this is how you will be able to analyze the problem in 3D and also solve it by using using manually. So with A dash as center, taking the radius of A dash B dash, you draw an arc such that both B2 dash and A dash are above HP by 20 mm. Now the line is parallel to XY in the top front view. Obviously in the top view, what is the top view of A dash B2 dash? The top view of A dash B2 dash is small a and small b2. How do I get that? You draw a line from B2 dash, you draw a vertical projector such that it will go to cut the locus of B in the top view, and you mark this point as B2, and since the front view line is parallel, correspondingly in the top view, that line is in true line. Therefore, you mark this as capital A and you mark this as capital B. Join AB2, which is little bit thicker than the XY line. So this is how you will be able to analyze and solve the problem manually and we are able to also measure the answers, that is the apparent length and also the true inclination with respect to both HP and VP. So this is how you will be able to solve the problem. Thank you.